Hello, this is Charity McKenzie with IDEA, and I am going to record a video on one-step equations. So one-step equations are kind of the basis of all equations. So it's the basic rules that you follow. So let's define a couple things here. Let me click this, see if it'll let me do this a little bigger. So let's define what an equation is, first of all. So an equation is a math problem with an equal sign. This is kind of small. So with that, it's going to have variables, letters, numbers, everything in it, but it has an equal sign in it. When we talk about equations, we are really have a whole different process than what we call an expression. So an expression is a math problem with no equal sign. So math problem with no equal sign. So it still has letters and numbers and different things. So if I said I have 2x plus 3x, that's an expression. It's just a problem where you can simplify it, but there's not anything else you can do except make it look smaller by adding or subtracting it. Also, like adding fractions or just regular division or anything like that is an expression. And the rules will always say, well, simplify. When we have an equation, the rules are going to tell you to do the opposite operation. All right, so let's look at some examples of these. So you'll have to bear with me as I do this because it kind of looks like second grader writing. All right, so if I have a problem, so the first kind of one step that we're going to have would look something like this. This is my first example. So if I have x plus 3 equals -7. And I want to throw in the negatives because that's always what throws people off a little bit. So on this problem, I have x plus 3 equals -7. And we want to keep both sides the same. Basically, we want to put whatever number in for x on the left side that will make that left side equal -7. Well, sometimes we can just see it. So you might already look at this and go, gee, lady, the answer's this. But some of you can't see that as easily and need a process. So what we do is we find the letter, which is our x, and we get rid of every number by it. And the only number by this one is a +3. And I'm going to get rid of that by doing the opposite of adding a 3. So that is going to be subtracting 3. So we're going to -3. And when you do that to one side, to keep it equal, you do that to the other. So if you think of a balance beam, if you took 3 off one side, you'd have to take 3 off the other, and that would stay balanced. And an equal sign is saying they're equal or balanced. So that's kind of the idea. So then these ones will cancel each other here. And on this side, all you have left is the x. On this side, you have -7 minus 3 more. So think about it. If I'm at -7 and I minus 3 more, I have to add more on that. So it's -10. Okay, and that's our final answer. So to check that, what I would do is I would put -10 back in the original problem where the x was, because I'm saying x equals -10. So let's check that. So if I put the -10 back here, I'm saying -10 plus 3 equals -7. Well, -10 plus 3 is -7. So our -7 does equal -7, or it balances, so it worked out. So my whole point of that first one step is if you see a plus sign, you subtract to both sides. Okay, so similar, what if I have a minus sign? Okay, so I have x minus 2 equals -5. So what number minus 2 equals -5? So I see a minus, so this time I'm going to add 2 to both sides. They'll still cancel here, so where you just have your x left. Bring down your equal sign. -5 plus 2 is going to give you -3. Okay, and if you go back up and check your work, -3 minus 2 more equals negative 5. So I put the negative 3 in for the x. Think about it, if I'm at negative 3 and I minus 2 more, I'm going to be at negative 5. So it does work out. Okay. So if I see add, I subtract to undo it. If I see subtract, I add to undo it. So now let's look at division and multiplication. So division and multiplication undo each other as well. So what if I have 2x equals 10? What does that really mean? Well, it's asking 2 times what equals 10, because we don't write the time symbol in between the letter and the number, because math people like to write the least amount that they can, so we don't add that symbol in. So if I see times, the opposite be to division. So the way we normally do that is we write it like a fraction under both sides. That's the same as saying I'm dividing by 2. So I divide here, and then you reduce on this side. So sometimes you can't reduce. I made this one easy so you can. 10 divided by 2 is 5. So our answer is 5. So what if that would have been a 3? You would have had 10 thirds. You would have kept it 10 thirds, and you're done. That's your answer. You reduce the fraction as best you can, but you don't need to change an improper back to a mixed fraction. Okay, last one-step equation, which we actually see the least, and most people mess it up the most. Okay, x divided by negative 3, or x over negative 3 equals 4. So I start with division because a fraction is division. So I'm starting with what number divided by negative 3 equals 4. So to get rid of this division, you're going to multiply, and this one's a little harder for me to show on the first step, so I'll just write it out. I'm going to multiply by exactly what I see in the denominator. So I'm going to multiply both sides by a negative 3. So I just put the negative 3 on both sides, and I added the dot that means times. These would cancel here, leaving just the x. So it has to be exactly, so if it's negative, keep it negative, so that you only have an x left on the left, because that's our goal, is to see what 1x is, or x. 4 times negative 3 is negative 12. So if you go back and check that answer, which I didn't check the third one, oh well. So if I go back and check this one, I'm thinking, okay, is negative 12 divided by negative 3, does that equal positive 4? Well, negative 12 divided by negative 3, if I think about just the numbers, 12 divided by 3 is 4. And remember, a negative divided by a negative is a positive. So that is correct. All right, so these are the 4 one-step equations, and they're the basis for all equations. Once you get down these 4 steps, it'll really help you with the multi-step and even the inequalities that we'll get to later in the year. So if you see add, subtract. You see subtract, add. If you see times, divide. If you see divide, times. And again, this last one we don't see as much, but I still want to show it.